Hello, welcome once again to a Somnofu online math class. In this video, we're going to discuss a very important topic in mathematics known as Pascal's Triangle. Kindly hit the red button to subscribe to my link, my channel. It gives you notification whenever a new video is out. Now, this Pascal, who brought out a way of solving binomial expressions, or the expansion of binomial expressions, has helped us a lot to tackle the difficulty of opening brackets like this. X plus 1, for instance, power of 7. Normally when the power is just x plus 1 to the power of 2, we just need to do x plus 1 multiplying x plus 1, which I know may not take you time. You get the answer sharp. But what if the power is 7? Will you continue doing x plus 1 times x plus 1 times x plus 1 into 7 times? You will see that this will take you a lot of time. Hence, to overcome challenges like this, we employ the usage of the Pascal's triangle. Now, I'm going to draw this triangle which will assist us in dealing with binomial expansions. Remember, when I talk about binomial, I mean 2. When I say binomial, I'm just talking about 2. Binomial is 2. Take for instance, when you have x plus 1 power of 3, how many expressions are here? They are just 2, 1 and 2. That's why it's a binomial expansion. But assuming in this x plus 5 plus, let's say, y power of 3, it's no longer binomial. 1, 2, 3 is a trinomial. But we are discussing binomial expansions using the Pascal's triangle. Okay. Now, this Pascal's triangle has a pattern with which you're going to use to expand binomials. For example, now, this is powers. Power of 0, power of 1, power of 2, power of 3, power of 4, power of 5, etc. and so on and so forth. If you have a power of 0, you are just using 1. If your power is 1, cover this one with 1 and 1. If your power is 2, for instance, just say 1 plus 1 will give us 2. Cover it with 1 and 1 again. If your power is 3, just say 1 plus 2 is giving us 3. 2 plus 1 is giving us 3. You see the pattern how it's going? Cover it again with 1 and 1. If your power is 4, just say 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is also 4. Cover it again with 1 and 1. If your power is 5, look at what it will imply. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. And 4 plus 1 is 5. Cover it again with 1 and 1. You can now see how we form beautiful triangle. Now these coefficients are what we are going to use to expand terms. So if you are given a power of 0, and you know it's 1. If you are given a power of 1, the coefficients you use are 1 and 1. If you are given a power of 2, these are the coefficients you use. If you are given a power of 3, you use this coefficient. If you are given a power of 4, you use this coefficient. And if you are given a power of 5, you use the last one. So I'm not going to introduce a question that will involve expansion of power of 4. Okay? So take note of these numbers here, because these numbers are what will help us to expand power of 4. I want to give a question that we're going to tackle using power of 4. Okay. Now, let's say we are asked to expand x plus 1 to the power of 4 using Pascal's triangle. Now look at what I'm going to do. The first coefficient here, because this is the power of 4 and our power is 4, so we are going to take this coefficient. Assuming the power is 5 here, I'm going to take the 5 fifth coefficient. If the power is 3, I'm going to take the third one, and so on and so forth. The idea here is to learn how to draw this triangle, the trend, how it increases, so that your power will determine the coefficient you are taking. And this is the power of 4. That's why I'm taking this to expand this expression. So the first item here is 1. So I'll have 1 multiplying. Whenever you see dots, know that dot is multiplication in math. The first item here is x, multiplying. The second item here is 1. Again, the highest power here is 4. Attach the 4 to x, then attach 0 to 1, so that 4 plus 0 will give you 1. Plus, the next coefficient is 4. So you have 4 multiplying x, multiplying 1. Now this 4 in x will reduce to 3. The 0 in 1 will increase to 1, such that 3 plus 1 will give us 4. Plus, the next coefficient is 6. It will multiply x and also multiply 1. The power of 3 reduces to 2, while 1 increases to 2, such that 2 plus 2 will still give us 4. Plus, the next coefficient is 4, multiplying x, multiplying 1. 2 in x will reduce to 1, and 2 in 1 will increase to 3, such that 1 plus 3 is giving us 4. Plus, the last coefficient is 1, multiplying x, multiplying 1. The 1 in x reduces to 0, while the 3 in 1 increases to 4, such that 0 plus 4 will still give us 4. Now, I'm free to clean this because it has done its own part. So let us simplify. 1 times 1, because anything power of 0 is 1. So 1 times x power of 4 will give us x power of 4 here. Plus, 1 power of 1 is 1. 1 times 4 is 4. So we have 4x to the power of 3. Plus, 1 squared is 1 times 6. We still have 6x to the power of 2. Plus, 1 power of 3 is still 1. Times 4, we have 4x. Plus, any number power of 1 power of 4 is still 1. X power of 0 is still 1. So 1 times 1 times 1 will give us 1. And this is the expansion of this, as simple as that. So instead of wasting our time saying x plus 1 times x plus 1 times x plus 1 times x plus 1 into 4 times, you see how Pascal's triangle has helped us to deal with this problem.
Hey there. Subscribe to my channel. And also press this bell icon.